The next part of Unit 3 had to do with what we did in the lab, the Icy Hot Lab. Okay, so I'm going to go ahead and write that up at the top. The Icy Hot Lab was an example of construction of a heating curve. Okay, don't forget there's just the opposite. We can also talk about cooling curves. And it just depends on the circumstances of the problem that we're trying to solve. But what we need to be able to do when we look at a temperature versus time graph, or we had discussed that we could actually call this energy applied, because throughout the lab our system, the beaker of ice and water, was setting on a hot plate. So we increase the amount of energy as we progress through the experiment. We need to be able to discuss the state of matter that exists as we go through a heating or cooling curve. We need to be able to identify if it's the phase energy account or the thermal energy account, and we also need to be able to draw particle diagrams. So at part 1, this part of the graph, because we see that we are starting below 0 and working up to 0, clearly that is a change in temperature, which means that is our thermal energy account. Anytime we see increases or decreases in temperature, those are our thermal energy accounts. Okay, and in our thermal energy account, that's where we're talking about the speed of particles, the motion of the particles. As we increase temperature, particles begin to move faster. On the other hand, when we look at the plateaus of a heating or cooling curve, in this region here and this region up here, what's happening there is that we are experiencing phase change. So down here, this is the heating curve for water. The freezing point of water is 0, so we are definitely starting out as a solid. But as we apply energy over time, that solid begins to melt and it turns into liquid. As we continue to heat the water, liquid water is the only state of matter that exists on the incline. And then when we reach 100 degrees, the boiling point of water, liquid is turning into the gaseous form. Okay, so we've done a good job here at identifying all of the things that we need to identify. The only thing remaining is particle diagrams. So when we are talking about the solid phase, this is where we're talking about, going back to the video I just created for part 1, solids are in an orderly arrangement. The attractions are strong and they're very rigid. As we heat up the beaker, the attractions are overcome and the solid starts to melt and particles are moving freely. So this is what our liquid would look like. And finally, when we get up here to the portion of the graph where particles are evaporating, we have to start losing some particles from the system. Okay? Because the attractions are even less, because particles of a gas will fill their container, they start to spread out, and as we mentioned before, in terms of those 3 vocab words that are important to know, down here solids are rigid, here in the middle liquids are fluid, and finally gases are easily compressible because of the large distances between particles. So if you can go through and do all of these things on a heating and cooling curve, you should be fine.